everyone. Welcome to Simply Learn. This is Shovik, your host for the session. I request all of you to confirm in the chat box if I'm audible or not. Thanks for your response. Thanks. How about others? Am I audible to you? Yes, kindly ping me on the chat box. All right, so I assume that all of you can hear me. So straight away I'm going to provide the presenter access to the trainer so you can start the session as per the scheduled time. And happy learning.
Thank you. I'm audible to you all. I will in 2 minutes at 9 sharp. A very good morning to everybody. Thank you, Pavali as well. So let's begin today's class. Thank you. Thank you, everybody. Before we get into the new concepts, we begin with anything new. Let's quickly revisit what we did the other day. So we two different ops, different statements of R. We started off with R the other day, and by the end of the session, we our discussion in statistics as well. Basically, descriptive statistics we got into because we would be at least requiring the understanding of basic descriptive statistical parameters. So, could you let me know what exactly was discussed by the end of the session? Did we cover standard deviation and Great. Okay. Okay. So basically, the other day, I only wanted to understand. We covered the other day what is mean. And we covered why we use mean, in which situations we use mean, and in which situations we use median. We understood that when we have extreme values in our data set, instead of mean, we rather prefer going for median to actually the central tendency. Problem at your end, Sudesh. Understood why we go for standard deviation and variance. We understood this concept that mean can be a very good parameter of male tendency. It can't be as well. Whether it is a good parameter or not, whether it is representing all the data set or not, that can be measured using variance and deviation. Whenever you present uh, the definition of any data set in front of anybody, if you are coming up with mean, you should also explain what the variance of the set is. Variance, we prefer standard deviation. We are the reason as well. We prefer standard deviation. And why prefer standard deviation? Standard deviation to we. So Sagar is right. We were standard deviation to variance because it is easier to interpret. Because standard has the same unit and of the data have the same unit. Will have if data has the unit of years, mean will again have the unit of years, and standard deviation will have the unit of years. If you talk about variance, variance will have the unit of years square. So it will be difficult for you to interpret. Interpretation as just users, it will be easier if you will come up with standard deviation. Or getting the concepts of mean, median, standard deviation, and variance. Understood quartiles and interval range. So explain that day that arrange your data either in ascending or in descending sequence, and you find out the middle number. I'll not get into the details because we all know how to find out the median. The middle number is your median, and if you'll ask me, I can go for that as well. The median. Median divides the data into two equal parts, 50% each. You find out the middle number, the median of the left hand side part. That median will be your second quartile, and find the first quartile, and if median of the right hand side of the data, that will be your third quartile. That median is nothing but your second quartile. Understood the other day that the difference between Q3 and Q1 quartile and first quartile. This difference is called interquartile range. Now, how we use interquartile range to detect the outlier, that was also discussed, but was by the end of the session. So some people are saying, let's revisit that. So let's visit that again. For understanding the outliers, Abel, am I audible? Yeah, audible. Thank you. Thank you. To understand the concept of outlier better, I introduced you with a plot called box and whisker plot. Box and your whiskers, these two. Just this thing that the middle, this box actually tells you the median, what median is, which in quartile as well. And left end of the box tells you about first quartile, and right side box tells you about the third quartile. This difference between third quartile and the first quartile, interquartile range, understood that way that we have 50% of the data contained within our interquartile range. When about the outliers, we have a good idea about the boundaries beyond which we consider a number as an outlier. So we defined that fence, we defined that boundary, and learned that if point is lying beyond, let's say, the left hand side of 1 minus 1.5 times IQR, data will be outlier. Or right hand side, so outlier can be a value which is way too less than the rest of the data points, or it can also be way too more than. So it can neither be too less, it can be too big as well. So outlier can be that value as well, which is more than Q3 plus 1.5 times IR. Okay. Now why this formula is chosen is it says some confidence interval. Navjot, to answer your question, signify any confidence interval as such, because here we know what type of distribution this data is having. We're discussing different type of distributions, but you need to figure out your outliers. If you don't know any distribution, if you're not building any model, you only want data which is a generic data which does not have outliers. So you can use this methodology. Otherwise, the definition of outlier audible? Bit better? Okay. Okay, thank you. Let me again tell you, in this particular scenario, we are not building any model, we are creating any formula as such, but yet need to identify those data points which are way far different from the data points, which are odd one outs. That scenario will be in this technique. We talk about this number 1.5 and this methodology. The methodology has come up out of research, is an industry practice. Okay, we can use. Ours will have a different role altogether. It will have a different play altogether. One will get into the model. In a model, when your model outlier is one which is affecting the model big time. Saying is your outlier. Then it will not depending on an individual variable. Then at that time it will depending on that equation, that relationship, that model. If any data point is affecting the model big time to itself, then that point will be the outlier. Outlier has different as when we come to the modeling part. But as such, if we are not getting into the modeling, again, be which will be helping your cause. Okay. Any question? Because this is a very generic scenario. You get to questions where you only need to find out the outlier values. Managers, top management comes to you that please take out the outliers. Tell what outliers are. So you can't pick up the big values and tell your manager or the top management that these are outliers. You should have some definition. You should have some empirical methodology. So that is something when here. The multiply with 1.5. Let me explain it to you. 0.5 we are taking, or later you will see some numbers like I'll take 30 as a number for the adequacy of the sample size. So numbers come from industry practices. These numbers come from a lot of statistical researches. So we need to get into the derivation of these numbers as such. Okay. Let me tell you one more thing. Some people get too much into outliers. They call all numbers which are beyond these boundaries, all these numbers which are beyond these boundaries, this number, I mean, all the numbers less than Q1 minus 0.5 times IQR, and those numbers which are more than Q3 plus 1.5 times IQR, all those numbers they call them as suspected outliers. And with our formula, 1 minus 3 times R and Q3 plus plus 3 times IQR. This is in the industry, just to tell you. So they say that if the number is less than times IQR, or number is more than Q3 plus 3 times IQR, that number will be confirmed outlier. So if it is less than this value and more than this value, 0.5, that is suspected outlier, and if it is more than this value, then it will be a confirmed outlier. So you take a methodology. If you don't have any model to build, you need some practice with the industry. So that this is a very information. Any question? I'm not like that. 90% of the data, I'm not saying like that. But you are saying, I know where you are coming from. From normal distribution. In normal distribution, we have these all things that we'll be looking into. But here, it is not normal distribution. It is any kind of data, any distribution. I'll repeat. Okay, so let me tell you. Actually goes about, I'll discuss an example with you as well. So if I'll quickly tell you this methodology, some people want to know this again. They could not expect the first time. So I'll tell. So we create two boundaries. First boundary is this, on which any number either more than Q1.5 times IQR, or it is less than Q1 minus 1.5 times IQR. If lying beyond that boundary, we will suspect that number to be outlier. Okay? Confirmed outlier. But if the number is more than 3 times IQR, or it less than Q1 minus 3 times IQR, if it's lying beyond the outer boundary, so you can call this as inner fence. 5 fence. This fence you can call as inner fence. This fence and outer fence. So it is lying beyond outer fence, that is confirmed outlier, but is beyond inner fence, that will be suspected outlier. Slides will be in between these two boundaries, and confirmed will be beyond this boundary. Okay. Now let me come to other questions. When do we consider suspected outlier, and when we actually go for outlier analysis? So that let me give a real example. Yeah, I'll tell you. A real life example. So this example I'll pull from Web Analytics, website performance. So we basically, so this is a real life example. This actually happened with me. Type of scenario came into one of the analysis one of the projects. So let me tell you about that. That will help you to understand this concept. So I was basically analyzing the web performance, how website is performing. So you say performance in the organization, performance should be related directly to the dollar values. So try to relate every type of performance with the dollar value. So the performance of a website, performance of the company, how you find your website is contributing in revenue or not. So for that we only consider the pipeline coming from the website, by prospects, because converting the prospect will be the responsibility of the sales people. Prospects is related to the web performance. So you had that's relying on salespeople, sales organization, but if you are getting enough leads, if getting enough prospects, that's something which will be a measure of website performance. Okay. We're looking at data of 6 months. Out of the 6 months, we were asked about age, age, pipeline size, average prospect size from each page. So each, I mean to say, for every vertical, for every horizontal, you have different pages. Mostly in any website, service lines you will have different pages. So basically, we wanted to see what is the average from different pages, from different verticals. I mean to say, from different horizontals, from different service lines, from different industry verticals. Average pipeline. So we were finding out the average. Obviously, the extreme values were creating the trouble. So extreme values, pages were showing a big peak. What we were asked to do, because everybody speaks about outliers, so top management asked us to take out the outliers and then do the analysis. How would I go about taking out the outliers? I can pick up the X values and then go about that, but you all know that that is not a right way to do outlier treatment. So why did the same thing? I found out those values which are beyond inner fence. So I found out those values and I presented the analysis in two. In first, in it, I presented the analysis with outliers. Okay, and slide I presented the analysis into two. First, those observations which don't outlier use, and also outlier values. So outlier information. So there. So I presented the information to two parts. The observations which don't have outliers, and those observations which have only outliers, so that people can understand what I'm taking out, what I'm taking in, and what if I'm taking everything in and one analysis. So everything should be very transparent. So I'll be showing, and analyst will show what data is speak. If data is not is speaking the way people want, I can't do, an analyst can't do anything. Presented those outlier numbers to the top management. What happened after that? So some managers in that present said that you have come up with these 5 outliers. Let me show. Are not at all outliers. You might be saying that these are outliers, but believe me, these are not outliers. Last year's website performance, last year's prospects and all, these type of numbers coming up very often. These are not outliers. Two of these numbers, they are like very big numbers, and you hardly expect these of prospects coming through website, coming through this channel. The type of deals actually come from sales organizations or from some big relationships. This don't come through website, I agree, but the 3 numbers, these type of deals keep coming. Since you are analyzing the data of only 6 months, just because of that you are getting as outliers. So maybe if you'll take the data of a year or 2 years, you will not see them as outliers. Have any learning, learn something from this discussion and scenario, I'm telling you. Basic learning here is whenever we do any kind of analysis, to marry our business understanding and mathematical understanding. Both things must be married together. Business knowledge and your statistical knowledge, empirical evidence, the things should talk to each other. If do each other, then problem. Maybe you are doing the mathematical analysis for business application. So yes, you may see some numbers as outliers. They not be the outlier. Big numbers, your sample might not be sufficient enough, and because of that, you are looking them as outliers. So because these terms come up, suspected outlier, confirmed outlier. Concludes, when you want to get the central value, you can derive the average considering outlier or not considering outliers. Take outliers carefully. Outs are not meant to be out of analysis. They actually give you some extra information. Always give you some extra information. So I came up with those outliers. So mathematics was telling me that these 5 numbers are outliers, but 3 of those numbers were actually not outliers. Those were some extreme values only. Those were some big values only, which are very often, which are very rife in business. So if you take so that is was suggested to me. If you take the data of 2 years, you will see these type of deals coming up very often. But important, you understand, it was important to me to check the outliers so that we treat them. The treatment might be different. So to aid those outliers, treatment might not be to eliminate. Treatment might be to sample size. Treatment might be something else as well. So when we present, so it should be clear to you, whenever we present any analysis, we always come with what we have done with the outliers. What are outliers? What type of values were the outliers? Otherwise, we might reach some wrong conclusions. The basic philosophy. Am I to all? If question, please let me know. This is a very important aspect of the business. Treat outliers and treating missing values. Both the things. with and without outliers almost same. What we do, if we data, it is much obvious that mean will not be same. Good. Hill is asking significance of outlier and its impact on the whole data. This thing. Nick, is your question or this is something which you have learned? Yeah, yeah. This is we learned. So will impact your data, will impact your analysis. So you detect those numbers which are actually impacting your analysis big time. You need to treat them properly. Thank you much. Let's do thing on R as well. Now let's find out a data set with outliers. Take out the outliers. Let's do something. Okay. We have some practical exposure as well. So request everybody to open R Studio. Yeah, great. So import this data house prices, which I have already given to you. Yeah, data again. Yes, now I'm doing the same. Download the data from this link, please. Share the data set with you, we shared earlier as well. The comma separate files, we are importing a CSV file, and because of that, we are using comma. So this is thing which we learned the other day, how to import a CSV file. That is what we are doing. Let's start our analysis. This is what I explained, Ruchita. Using SEP, it is a formulation. What is delimiter we have used? So delimiter we have used here is comma. It is a comma separated file, CSV file. When you save this file, please save it in CSV format. It again. Need to write this line of code. Let me put this line of code as well. And run. Once it this type of pop-up will come up. It help you to import file. You can select the file wherever you have saved it and import. Well, so let's see what we have in this data. I head. So these all things we did. How prices? The price, area, bathrooms, bedrooms, size, age, and fireplace. So this is the data set. This is the case study, which house prices of different and those factors are mentioned here that are affecting the price: living area, bathroom, number of bedrooms, age, whether that house has a fireplace or not. So all information is mentioned here. So you are interested in this variable and you want to see if you have any outlier in the price value or not. So what I'll do, let's do it this way. All the tools, we understood the concept. So conceptually we are well versed. Now you need the tool, you need formula. I'll give you the formula and you tell me, answer my questions. So I'll tell you the formula for quality. So what all need go about in any business situation, and let's do it in this way only here in the class. So to take the outlier, what all you need IQR, interquartile range, and you need Q1 and Q3. That is all you want. That is something you can find out easily. Function which use one thing. Let's use attach and let's attach this data set so that we can use the name of the variables directly. So quantile, mention the name of the variable price and mention here 0.5 will give the value of the first quartile. The first quartile divides the data into 20% and 75%. So first quartile is coming out to be 1014. Okay, you find out quartile. It is tile. Some people call it quantile. If you'll take, that will be your second quantile, and that it is a median as well. So let's see whether it is coming out to be equal to median or not. Yes, it is coming out to be equal to median. And if you're looking for third quartile, it is 5. Find out first quartile, second quartile, and third quartile. Let me paste the code here so that you can do it quickly. But attach your data before you this code. Otherwise, I have to use that dollar sign. So this you find out the quantiles. The second tool, the second formula you want is quantile range, which is also very easy. You can subtract the two quantiles, or you can use IQR directly. IQR, or let me capital. Please make sure you keep them capital, and it will give you the value of IQR. Now, whatever you have in Excel, you all understand at least how to make the filters, use the filters. If you don't know, don't worry, then might not be able to solve it, because you only need to know how to apply filters and how to use filters. You tell me how many outliers we have in the data. 1 minute. Whether you are able to understand my concepts, whatever I have taught, whether you are able to follow that or not. Check your knowledge as well. Let me know how many outliers we have in the data. Yeah, attach so that we don't use the name of the dataset time and again. Otherwise, we would use house prices dollar price every time. Then always use the name of the data set dollar, name of the variable. So in you are working on only on data set. Outliers, Nakesh is saying. I will wait for another response, one response, and then go ahead. One response. One response and go ahead then. So Nayan and Nagesh both have come with the same answer. Let's discuss now. It's simple. I don't know what made you confused or what not able to do this. So we only need to look at the inner fence, fence. So let's, Swan is also coming up with 17 out there. So I believe 17. So, uh, so we need to look at the boundaries. So let's first of all create the boundaries, and then we will see what all values are lying beyond those boundaries. So first of all, let's create the is also coming up with 17. Good. So now enough people. Great that you people are following. So third tile, obviously, 1.5 times IR multi price. So the fence, this will be upper fence. Sorry. Talk about on the left hand side, it will be 1 minus 0.5 times IQR. If you look at these values, these values are coming out to be 27,817.5 and 345,066.5. Okay, let's look at these values, what these values are. So basically what we learned, that I have a box and whisker plot like this. We get this is inner fence, this is Q1 plus 1.5 times IQR, and is Q3 1.5 times IQR, and this came out to be like this. So came out to be equal to minus 2787.5, and value out to be 3466.5. Only those values which are lying beyond fence. So if at the Excel, that C file, you will see no negative value. You will see any negative value. So you can say that we don't have outliers as very less value, because outlier can also be that value which is way too less than the rest of the values. Don't have any case here in this data. So in this data, if you look at the data, you have all the positive values. So there is no value which is less than even 27,817.5. So I have to look at the outlier values only towards the right hand side of the data. We will do that. So we'll open Excel. Excel for you. We'll apply the filter. We'll open the price. We'll number filter. 11 बजे लगे. And then we'll mention greater than in that we can list number the rudimentary way. There are many ways. So all were right. I really appreciate you all. The 17 outliers. So how we do in Excel if we don't know many things? Let's do it in R. Question so far. If you want a question. There will be plot as well. No problem with that. Uh, if there are two data points having same value, then we should count them twice. We will count them once. You will not count them twice. But here we were not looking at the data values are same or not. We only wanted to look at observation. So here we have 17 observations. Okay. Right. In this particular scenario, FL is not useful here. Okay. Okay. Now let's get into R and see how we can do this. You can do this using subset function. Subset function, you only need to mention set. So say is the data set. Outliers are the values of some specific variable. So let's tell you how we go for any kind of big analysis as well. So whenever you go for any big analysis, like if you want to regression, okay, to use the technique regression, how will you go about that technique? So first of all, you will look at each and every variable. You will see what variables are, what is their distribution, what is the median value. So you will look at, so because that it takes time for any analysis, you look at each and every variable, each and every variable, and then you go for analysis. You're right. Code for your reference. Use a function called subset function. We mention our data. What is data is house prices. Mention the condition with respect to which I want to sub. So subset means taking a part from the data. Taking out one small part from the data. That is subsetting of the data. So we want to take a part, suppose it has only the outliers. So how we go about that? That price more than do just a moment. Do FU we can distribute here. Text now it will show only those values which are in terms of price. Yeah, as well. We can as well. That this is you all understand that we can use that as well. What I'm saying, suppose I want to take out on those observations, need to deal with only that data set. We only of price. You need to see your data. So use a function called subset. In subset function, you will mention the name of the data. That you will mention the condition with respect to which you want to subset your data. So the condition price should be more than this value. Those observations, set house prices, only observations in the data set house prices for which the price is more than this value. That as well. The operator which is for or condition, and we can other condition just after that less than. Okay. So if we'll make and condition, that will be another thing. Multiple conditions can also be mentioned here. Okay. I mentioned this 2 should be minus. Okay. So conditions we can also mention within set. Yeah, a few variables. Instead of typing this whole thing again and again, what we do, because this is something we have already calculated, so what we can keep this as FU FL we can do as well. Any So find out the count. You can use nrow function. Nrow function will give you the count of that. Okay. Maulesh, we have two functions. So here the list is a big list. So you can go to Khan website and you can look for thousands of functions, but that will not help you. So learn these things step by step. Okay. I'll be giving you a formula. I'll be giving you these all things and required. And by the end of the course, you will have the library of all the formulae which are actually required. And uh, if you want to move fast or you want to be ahead in the curve, you can always refer to that PDF document here with you. One, three, four, five, six, seven. You have 7 columns. Where do you see 8? That column, that is an index. How many you have in this? 1, 2, 3, 4, 5, 6, 7 columns you have. Yeah. Okay. Only 7 columns. And is the count of rows and n called actual number of columns. Okay. So confidence of his face feeling with R. I want you people to be uh, some confidence. Okay. Gain some confidence before we get into core programming things. Yes, we'll be doing loops, we'll be handling condition statements, but I don't want to throw very technical thing at the very beginning. Okay, so let's first of all be comfortable with these basic things, and then we will cover that as well. Okay, so now we have covered. Yes, I mentioned that PDF document which must have been shared with you over the LMS. You need to download that from that portal. Okay. You. Okay. So now, if you we have covered more things in terms of descriptive statistics. Apart from concept of skewness, I'll be covering kudos as well, but after understanding of normal distribution. So skewness is a word which people use very often. Skewed, you skewed. Okay, so what skewness? It is negatively skewed. We use this terminology a lot, making much of it. Okay. So basically, you are coming to the point of concern. Here, look at the distribution of the data. Refers to distribution of data to all AMPs. Okay. Data I also use Teradata SQL assistance to data. But I'm not the expert as far as the data management part is concerned. I'm more inclined towards statistical modeling, machine learning, and implication to the business. So I'm very close to the business. So I might not be able to understand the very technical things in terms of data management. Yes, I use these all tools. Okay. And if you want to share anything with others, you can always share. It will be helpful for everybody. Okay, thank you. Let's see what it is. Suppose you have a salary. Here you have number of employees. So you have number of employees. Number of employees, or you can also call it frequency. See, I believe you understand. Frequency means the count about gender, suppose. Multiple values of male, female. If you find out what is frequency of gender, so it will include the information about the count of male candidates and the count of female candidates. So find out what two variables are saying to you, how these two variables are talking to each other. So if you will plot these two variables on the Argand plane, something like this. The axis you will have salary, you will have frequency, number of employees. Okay. Don't you think the graph will look like this? Or correct? Or the graph will so if salary of the employees for an organization and the curve you will see. So most people have will actually look at a curve very similar to the second one, which is present on the right hand side. How don't agree with me? Many of you are saying it's first one, or it is neither of these two. It should be something else. So let's see what will you read out of this curve. This curve, you will see there are people. So this is when see the number of people. There are people actually lie in this range. There are very few people who have very less salary, Am I audible? Okay. Is it good or good enough to understand or okay? There was some issue at your end. Okay, but good to us all because it might be at my end as well. So please, as you face any issue, so that I can take off it if it is at my end. Thank you. Look at this curve, you will see there are very few people who have very low salary, but most of the people having the salary around this region. So this you see most of the people are having. But look at big salary values. There are very less people. I think which happens in any organization. Big values you will see only for some top management people. And if you look at the curve of any organization, it will be this. At the top, you will have very less number of employees. And you will have more number of employees here. Here you might see less, something like this. They are getting very low salary as well. You can see this curve. Good. In any organization, you see the salary trend like this. This is called plotted salary in the x-axis. Is there any reason? I think it is better to plot on y. Salary either on x or on y-axis. I don't know, but it is more convenient. It's more convenient for most of the people if I'm plotting salary on the x-axis, and because of that, it is a convention which I'm following. So, this is a convention which I'm following. Otherwise, again, you can put it on well. No deal. And then something like that, which might be easier for you. On least over the period of time, what type of curve you have seen. So it might be easier for you, but for most of the people, it is more convenient to look at the frequency like this. So because of that, okay. Anybody, any question? So this curve, which is on this curve, is called right skewed curve. So this is a skewed curve. Skewed. Why it is called skewed? Whether it is right or left, both diagrams. If you see, these are skewed. Why skewed? Because these are not symmetrical. These asymmetrical curves. So if it's a symmetrical curve, you will see something like this. Frequency value. Here, suppose metric curve, it will look like this. Metric curve, where is your mean? On the right hand side of this line or on the left hand side of this line? Yes, on the line. So you your mean here, right here. This where again be the same. The mode again be the same point here. So if a symmetric curve, so will again be the same, and at mode that again lie here at this point only, because mode is nothing but a value which has maximum frequency. Yeah. Some deviation. So very symmetric curve is something difficult to find in the real life scenario. You have some kind of skewness for sure. So when you are made, then they try to make it very symmetrical. Any can give me the example of this negative skewed curve? Example, if you can give, think it. Can give some example for skewed curve? This is mentioning stock value. Stock value and frequency in terms of number of time. Yeah. You, yes. Good. You people have started thinking. So this is called data acumen, which you people are developing. Great. Highly appreciate your responses. Example, a very simple example. Suppose here you have a edit. Suppose after completion of this program, to go for some multiple choice question, and you to that there will not be a certificate unless you will pass the exam. And they suppose infinite number of attempts you can make. So unless you will pass exam, you will not get the result. So here on the x-axis, I have attempts. People made to exam, get the certificate. I problem is at Nikhil's end only. All of you can hear me? Yeah. Problem at your end. Problem is at your end. Yeah. Attempts we have here on the x-axis. Number of attempts before a person gets the certificate. Pass exam. Axis you have number of people. You there are 20 people who will take many attempts to actually pass the exam. There will be fewer people you people to pass the exam only one attempt. I'm pretty sure about that. But yes, if you take a generic case, there will be more number of attempts for most of the people to pass the exam. Okay. Anybody question? Okay. So if you talk about skewness from minus infinity to plus infinity through 0, and calculate skewness using this function skewness. Not able to find that function skewness because there is a package called moments which we have to install before we can use function skewness. Moments everybody needs to install. I know how to install a package. Install dot packages moments. Okay, and to call it from the library. Install this package. Confirm once you are done. Go the result as well. Very nice. All you need to install it. Once you have installed, then you need to call library. So let's do it one by one. Package. Kita, if you're not able to find the package, uh, did you use this option L? You, if you look here, moments, click install. It will help you that way as well. You can do this as well. If you're not able to find the package, you are not able to install it, then you might need to install R and RStudio again. You missed few files. Sometimes once you install. The operating system. I'm on mad. So here the skewness value coming out to be 0.874. Some files missing in the installation. I was in one of the guest lectures, one institute, and I understand a few things in R as well. So same problem happened with a couple of people. So depends. Please reinstall it. Okay, so this is the way you find out the skewness. Here you see a positive skewness. What price values? You must attach it. If it to do it this way, house price can use. We have given here. This as well. If you have not used attached, I'll be taking up separately. I'll be taking up different methodologies. You create. So visualization will be taken up separately. Okay. Ideal skewness an organization is trying to maintain. Why organization maintain the skewness? Different variables will have different kind of skewness. Able to understand the question, Ankita. Okay. So let's go ahead. Do you have some other question? Yeah, tell me. Doctor mentioning, I believe this was discussed. When you need, so as you use, when you need to deal with one data set time and again, and when you with multiple data sets, you can use this dollar sign to mention which data you are referring to. Suppose this is present in multiple variables, multiple files. How will R get to know that you are taking place from house prices file? Shankita. In Excel, dollar sign is used for some other purpose. In Excel, we use dollar sign to fix the values. In Excel, we use dollar sign to freeze the values. We use dollar sign after the column or row. In case you are right. So it's about table name, column name. Yes. So it just tells you about whether it is a positively skewed curve or a negatively skewed curve. If its value is coming out to be positive 0.87, it means positively skewed curve. It uses the symbols differently for different purposes. Yes. Positive is rightly skewed. Yes. Negative is negative skewed or left skewed. Both you can use. In each tool, you use a different language for that tool, and you have to use a different syntax for that. Okay, so go ahead and get into normal distribution now. We have enough in descriptive statistics. Now let's get into normal distribution. infer from this perspective? From this perspective, what we infer out of it is simple that there are many houses, so it is skewed curve. If you have a graph like this here, have frequency values. So here it is a positively skewed curve. It simply means that some values which are very high. Values are not for many houses. There are many houses which have average price values, less price values. Few houses. There are few houses with high price values. And why number is coming out like this? Because we have 17 outliers as well. Outliers, and you see only one value for those outliers. So you have some big numbers, but frequency of those numbers are not very high. So there are not too many houses with very high values of a price. That's something you can infer, Ruchita. The skewness for fireplace, in the value, it is either 1 or 0. It is a categorical variable. It is variable. Uh, let's take up the example of frequency and salary of an organization. What would be the ideal skewness they want? Okay, I'll tell you again why they would look for the ideal value of skewness. It is a very generic scenario. So organizations can be of two types. You have an organization which has approach hierarchical organization in which you have 1% at the top, then 2%, then 3%, and you have one, and then you have with a thin roof. That is your hierarchical organization. You can have something called this structure where you have everybody much same, so everybody at the same level getting same kind of salary. Suppose you are working with a certain firm. In a certain firm, you have a very small company of about only 25 people, and most people are consultants. So you will have the same salary for most of the people. And in the case, uh, you have any hierarchy in that. So any hierarchical organization will have the skewness like that. Maintain any skewness as such. Type of organization you have. Ankita. Okay. Now let's get into normal distribution. What is normal distribution? We have a lot about that and how we use normal distribution. Let me open a pane to explain it to you better. So distribution, if we need to understand a few things, that first of all, normal distribution is created only for continuous data type. Continuous data type, I mean to say height, width, marks. So these are continuous variables. Numbers, count, that will not be continuous. If you put number of bathrooms, number of bedrooms, that will not be continuous. So if we talk about continuous variable, then only we can discuss about normal distribution. So data should be continuous. Uh, you need an understanding of PDF, probability density function. Density function, and here x can be your price, it can be your height, width, whatever you want to call it. Very generic scenario which I am putting forth here in front of you. So on the y-axis you have PDF probability density function, on the x-axis you have x values. What is probability density function? As the very name suggests, it is the probability density. You will look at curve. This curve view the value of the probability. So probability per unit area. Okay. So how this area gives the probability value. So this probability per unit area, and if multiply it with this width, it will give you the probability value. Strictly, A under the curve will give you the probability value. And so I will come to the business. I will come to the examples as well. I have a lot of examples to discuss, but before that, we have to understand the mathematical aspects as well. Okay. So let's first of all understand the mathematical aspect. Then we will get into the application part. We have understanding in terms of mathematics, in terms of formula, and then only we can get into the application part. If you need to define what is a normal distribution, so first of all, people have, let me clarify here, people have this misconception in their mind that normal distribution is something which is normal and everything is abnormal. Have this misconception in their mind that there is something normal, everything normal, and there's something abnormal. It is not like that. In statistics, in data science, you have types of distributions. Distribution we learn because many statistical techniques are based on normal distribution. Based on normal distribution, that we will get to understand after the learning of central limit theorem, which we'll be doing after the break. Get to understand why we use normal distribution, but it is definitely not like that it is normal and rest all are abnormal. Distribution has some properties. Let's discuss about those properties. So if you talk about PDF, specific function, there follows a specific function, which the function is something like this. Need not get into mathematics too much, but I'm showing you. This is something like this: 1 divided by 2 pi sigma e raised to the power minus 1 divided by 2 x minus Now, what is sigma? Mu is the mean, and standard deviation is your sigma. So, look at this formula. You will see on two things you need, parameters you need. You need to assume any norm distribution are mean and standard deviation. To define normal distribution, you only need two things, that is mean and standard deviation. As far as normal distribution is concerned, since this area under this curve tells about the probability, total area under this curve, whole area under this curve will be equal to what is total probability? Concept of probability long time back. Yeah. Total area would be equal to 1. So T will always be equal to 1. So normal distribution is a symmetrical curve. So, me lie here at this point. So here, about line, it is a symmetrical curve. So if you talk about this line mean, this line divides the data into two parts. The area under the curve on the right hand side will be equal to 0.5. Thank you. Thank you. Thank you. Thank you. What I mean that area under the curve is 1. This line mean divides into two equal parts. So area under the curve on the right hand side will be equal to 0.5, and area under the curve on the left hand side will be equal to 0.5. Okay. Just got by this. Most people who have learned it in the past for 30 seconds, if you learned it in the past, please forget whatever you have learned, because you learned the very academically. So in academics, you hardly use any tool. So you look at the tables. You look at Z table, you look at T table, F table, those tables, logarithmic tables. You look at those tables which are present at the back of your book. So from there, you need to forget that, because we will be using tool, and the process will be very smooth, very easy. Find out the probability value. Use that. How do you find that? I'll show you. This is the data of score. Okay, here you have SAT scores as X. Here you find out the number of people, probability of finding out the number which is less than, say, 700. So the probability of finding a SAT score less than 100 can be represented like this. Giving you that probability. This is the probability of finding out a score less than 700, and this probability you can find out by using the function P-N-O-R-M. It'll put 700 of x, and then of distribution, mean of SAT score is the deviation of SAT score as the input. You give the probability. Here, if we know the value of x, we get out the value of probability p by using the function p. What are the inputs? You will be given value of p. You will have value of p, and you would require to find out the value of x. So you will be using norm. You will have p probability as an input, in x as an input, and finding out p. In Q now give p as input, and you will be finding out x. And third, in both the functions will be the same, mean and standard deviation. One basic example to understand this. Let me share one document with you all. We have a list of very basic questions, some examples to help you understand these statistical terminologies. Just a sec. Pasted the link here. Wrote the file. Pick up some questions. The is probability here calculated using same formula, number of observations divided by observation. The formula is from classical definition of probability. The basic same that we only, but here you see the probability is calculated using using under the curve. So different methodology altogether. So commands have been simplified here. Yeah, you are right. So done by the tool. Yes, you need to have that basic concept in your mind. We will solve one question. We'll use directly in RStudio. Martin will do that. This document earlier as well, so I again gave it to you so that people could not download it earlier. No. I'm not aware about any certification for our. recognized worldwide. If you people know, uh, please share your views. I am not aware about that. Question before the break. Take up the first question. That problem of what score, the mean is coming out to be 494 and the deviation is coming out to be 100. You need to find out the probability that a randomly selected score is between 600 and its mean. You have business examples following, but let's first of all the basic. Let's start with this example. So here the story is about the series about scores. Mean SAT score is 494 and the standard deviation of SAT scores is 100. You need to find out the probability that a randomly selected score is between 600 and its mean. How will you find that out? So I shall wait for 1 minute and I'll see how many of you are able to calculate it. It is very easy. Martin has a different answer. Skaria has come out with 0.98. So do Amit and Bhavna have done. Okay, let's do it. Let's understand what is the problem. So when you are new, so we are like the toddler in of statistics. So whenever new, we should start from the scratch. And jumping into the numbers and the formulae, you will see same kind of formula coming up time and again. Okay, need not to jump into the formula, need not to jump into the numbers. Let's understand what is the requirement. So first of all, I'll build the normal distribution. For these scores, probability score selected will fall between 6 mean. Mean has been given to you. It is 494. Write this normal distribution in this way: n 4, comma 100. 100 is the standard deviation. Yes. So now deviation is like this. 600 and mean. So 600 will be here. And 494 mean is here. 600 will lie here. We need to find out this probability. The curve between these two numbers. Out this area. We learned from the formula that if the curve this and this area area out using function, I can put the value of x. So if this is x, we can put x, we can put value of mu, and we can put the value of sigma with the value of probability. Here we are looking for some other number. Here, we for this area confined between 494 and 600. With what we can find out with formula, we can find out the area until from extreme left. So there we can find out. They find out using p norm. So in p norm, if you'll put 600 as a value of x, 44 as the value of mu, and 100 as a value of sigma, we can find out this area. Find out this area. So what we need to do, we need to find area and this area which is on the left side of this normal distribution. What is dotted area? On the left hand side of the mean, what is this area? Point. Yes, learned this thing. That this whole area under the curve is 1, and this whole area is divided into two parts, two equal parts, 0.5 each. So 0.5 will be the area lying on the left hand side of this symmetrical normal distribution. So we subtract this area, this whole area, this point from this whole area, we will get the desired area. So the answer would be P 600, 494, 100 minus 0.5. So the right answer would be 0.355. Any question in this? So let me just look at it. Ravi was right. Right. So two of you were right, Martin and Ravi. Well, but I highly appreciate everybody because you applied what I've learned. So this is you learn by making them errors. Very good. In a different way as well. Both as you can find out. So 600, 494, 100 minus 4.4, you will get an answer. In this case, we know that it is a normal distribution. If we'll have follow distribution, it actually follows, and the form into that. Calculation, we can always use that PDF formula, and we can go for the integration. So if you talk about thing, it will be PDF function you can use, and you integrate 4 600. Is P norm minus 0.5 or 0.5 minus P norm? Don't you if 5 is at value, so 4 will lie on the left hand side of 600. 600, the area under the curve until 600 will be more than the area under the curve until 494. You. A curve until there, until 4. So 494 is this point, 600 is this point. Area under the curve until 494 will obviously be lesser than the area under the curve until 600. We will subtract the area from the area. Okay. So this is a example where you have been provided that is a normal distribution, and you have to apply the formulae which are pertinent to normal distribution. Okay, so we'll do rest of the problems and we will build on these concepts after the break. Um, let's break for 10 minutes. Take a sip of the coffee. Okay, splatter. Come back after getting rejuvenated. Thank you. See you after 10 minutes. A quick response from everybody, whosoever is back. Let's start the session again. Question in the last problem we solved. Okay, let's do one thing. Let's solve one more problem. Ending of it. Third one. Fourth. That's these two questions. Solve third and fourth. No. My screen now. No. Yeah. Please solve question number 3 and then question number 4. Okay. 3 Martin is it's 71.2%. You can solve second as well. I only wanted to solve one, and then rest of the questions I wanted you to practice, but since there is some problem, so let's solve these two. Like very questions. Let's take up second as well. Okay. Third and fourth. Let's try all the three. I'll solve it for you now. Everybody for your responses. Number 2. What is the probability of obtaining a score more than 700? Again, draw that normal distribution like this. The mean of this normal distribution is 494, and the deviation of this normal distribution is 100. So I highly appreciate people like Martin, Ankit. They have solved all the 4 questions, and they are actually very easy. Very good. Bindu, let's do all these questions. 494 here we have. This we have as 494. Look at the question. This is the probability of obtaining score more than 700. 700, if you look at 700 will lie somewhere here. 494, this is 700. We need to put the probability of obtaining score more than 700. The area we need to find out. We will back function we learned. That function gives me the probability from the extreme left. This probability this function gives me put the value x mean and the standard deviation inside this function. X, mu, it calculates the probability. So basically, it will find out p norm. Oh. The value of p norm taking 700 as the first argument, 4 which is mean as the second argument, and 100 as the standard deviation the third argument. Value p norm probability will be under the curve from the extreme until this point 700. Area is given by norm. This is something we have understood. Anybody in this? I'm being slow here because I'm not able to solve it, so slow for 1 minute. So AI is something which you can find out using p norm, but looking for this area. You are actually looking for this area, these two areas, this area and this area. The sum of these two areas is 1 because the total area under the curve is 1. So if I will subtract p norm from 1 area, which is the desired area, so the answer will be 1 minus p norm 100 4, 100. That answer to question number 2. Then 550, it is very straightforward. So question, the solution is this. Is very straightforward. Score less than 550. I'm able to solve question number 3. Simple. Norm 94, 100. Very it is. And last one is up between 300 and 600. Let's go. $494, 300 and this 100. Put this whole area until 600, this whole area under the curve until 300, and then you will subtract the test to get the answer. Yes, not right. It is simple now for you people. Now 600, 494, 100 minus 494, 100. Let's go ahead now. Understand something is very, very important in terms of initial statistics. A platform where you start inferential statistics. Do you have any problem with these 4 basic questions? I can explain again. Big deal. Good. Let's understand this. Yes, business applications are coming here. You see, all these problems are business applications. Will be done with these basic things. Then we're getting into the data and we'll be doing it on the data. Okay, good. Concern about this aspect, and this aspect is more important than anything else. I'm going to discuss a very important theorem. It's central limit theorem. Basically, what we do in inferential statistics, we don't know much about the population, and we try to estimate for the population, and for that we analyze the sample, and from that analysis of the sample, we estimate for the population. That is what we do in inferential statistics. An experiment was performed, and I'll show you the outcome of that experiment, and those outcomes are actually very important for our analysis, because it is very mathematically intensive, and you need not to go for the derivation of it as such. What suppose a population is considered, this population, take the example of your class. You have different students in this class taken out samples of 10 students. So here you have the students, experience of different students. Here you experience works of different students. Taken out the samples here. So size 10. Unit experience values 4, 10, 5. Okay, you have different experience. So these samples have taken out from this population. The experiment do anything at any point, please prompt me then and there. and I need your utmost attention for next. Center limit theorem will be the easiest thing for you. Otherwise, get it, and it will be difficult for you to develop understanding of it. We have taken out the sample of size 10 each. Notation purpose 5, 6. Okay, these we have taken out. We have population, and the population mean is mu. Population mean, and the deviation is sigma. These samples, and from these samples we found out the sample mean. So sample 1 found out the sample mean. I'm calling it as x1 bar. This is again a sample, second sample, and I am finding out the mean of this sample, and I'm calling the mean as x2. For example, it will be x3 bar. The fourth sample, it will be x4 bar. We observed a wonderful pattern distribution of these values. Mean values. Experiment, we know everything about the population as well. So we found out the population distribution. Division is sigma. Population okay. Repeat. I'll repeat. Central limit theorem. We picked up one population for the experiment and found that the population mean is mu and the standard deviation is sigma. Experiment, we took out sample of size 10. So we took out different samples of size 10 each. Found out the sample means of those samples as well. Like for this we found out the sample mean as 1 bar. For this sample 2, we found out the value of 2 bar. Like this, we did it for these samples. a wonderful trend. I'll tell you what that trend was. This experiment was done for different types of population. We saw when the population is normally distributed. When the population is normally distributed, the distribution of these values, these sample means x1 bar, x2 bar, x3 bar, the values are also normally distributed. Have x bar, distribution of sample means distribution of when the sample size was 10 sample size, this distribution of sample means normally distributed. Sample size was good enough, it was 50. Again, that means to be not distributed. It is again the distribution of samples. So sample size is good enough, whether the sample size is adequate or it is not adequate. In both the situations, we saw the distribution of sample means to be normal. Population is normally distributed. Not a surprise for me as well. Which I had, which those people who this experiment had, was something very fascinating. What they had, they looked at the populations which are not normal, which have some other distribution. Those populations, if the size is not adequate enough, if the cell size is small, they say anything about that population. Sorry, distribution. So if the population distribution is not normal, sample means you can't tell about. You know what type of distribution will have. These use x1 bar, x2 bar, these use you tell about distribution. Sample size is adequate enough, then the distribution of sample means will again be normal. This is something big, don't you think so? You don't know anything about the population distribution, but if the sample size is adequate enough, distribution of sample means will be a normal distribution. This is a very important statement of central limit theorem, which is used for inferential statistics. So I'll reiterate what I have said in just 2 minutes. In 2 minutes, if the population is normally distributed, all the scenarios of size, the distribution of sample means will always be normal. If the population is normally distributed, distribution of sample means will be normal. If not normally distributed, then you can anything about the distribution of the sample means if sample size is not adequate enough. But if the size is adequate enough, then the distribution of sample means will be non-distributed. Adequate size. People who are talking about practical uh, again, they need to understand that we have to go to the conceptual part as well. We just can't get rid of statistical concepts. We have to go for that. Yes, we'll be discussing with the help of data. We'll be having a lot of questions. I showed you that thing many times. You have these all questions, here, practical scenarios only that we're getting into. But you need to develop the concepts before that. Jump into the problems and solve those problems right away. We need to get tools. We need to get those concepts which will be applied on that. Okay. So you need to focus here to avoid this for sure. Two. What determines if the population, if the distribution is normal? If the distribution is normal, it will follow that focus, that function I discussed. The P will have that value. It will follow that function. Normally, it simply is that it is not following the normal trend. It is following that function. Trying to solve here in simple terms. We have to develop a relationship between a sample and the population, which we do in inferential statistics. So at the outset, when I started off with central limit theorem, I mentioned that this is the platform from where you start. So we'll see that central limit theorem connects a sample with the population. So you're able to infer for the population, you know, the sample with the help of central limit theorem. Look at what I mean by future population. You know what is future population? What is past population? Not the case. Try this. Let me verify here about future or past. Let me give you one basic example. This is a theorem. This is an experiment which I'm discussing with you. From that population, you are taking out the samples and you are analyzing that. This is the experiment which I'm discussing with you. So, what kind of scenarios it will be helpful in? Discussed with you in the first class and in the second class when I was explaining you the difference between inferential statistics and descriptive statistics. That when you need to tell something about the population and the population is pretty large, you need to find out the satisfaction level of your employees. And you are a big organization across different geographies, employees working in different time zones. You have business units, different priorities. It will be difficult for you to reach each and every employee, fetch the performance is the satisfaction index for the employees. It will be difficult for you. So what you will take out a sample. You pick up few employees. You do the survey. You will ask the question from the few employees, and then you will interpret. You will inference. You will take the estimation for whole population. That is what you do in inferential statistics, and that is what we will be doing. Yes, Shan. Okay. Yes. Okay. So to do that, we need a theorem. We need some technique. That technique is central limit theorem. Explaining you this technique to you, I am just mentioning the experiment which was performed to derive the results I'm doing. X-axis you have any variable x, or y-axis you have PDF, probability density function. I'm sorry. So I'll again. Population is normally distributed. If population is normally distributed, the distribution sample means normal. The distribution of sample means be normal, irrespective of the sample size. I have a statement. The distribution of sample means will be normal if size is adequate, irrespective of the distribution of population. If how many of you are not able to understand? I'll reiterate what distribution of sample means normal if the size is adequate enough, irrespective of the distribution of population. How many are able to understand this? This is about the population, and something which will be the case. You don't know anything about the population distribution. Irrespective of that, of sample means normal. And inflation. If you want to say in statistics, that in statistics, I have explained to you before, but let me tell you, inferential statistics you use when your population is big enough. The example which I have just given to you, employees satisfaction score. Another example, pre-poll. Okay, I'll question Manjut, but how is possible in case of distribution of the population is not normal? Derive out of central limit theorem. If it's not normal, the distribution of sample means, please remember this thing. The distribution of sample means the sample means. It is not X, it is not sample. It is sample means. Times because people keep getting confused. This is what the distribution of sample means. You can out the sample and you find the means. I'll pick up another question. If I don't know anything about the population distribution, how can I know whether it is normal or not? Scaria anything about the population distribution, but central limit theorem tells you distribution of sample means normal. It's not about that sample values, that full numbers. It is about those sample means. Jyot, what if we take two sample having same size, but for sample distribution is normal, another is not normal? When we talk about sample distribution here, Navjot, you're not listening to me carefully. The word I talked about the distribution of sample. I don't care about the sample distribution. Here, if you talk about central limit theorem, talk about the distribution of the population. So, population distribution we don't know. If we don't know about the population distribution, but have the adequate sample size, the distribution of sample means will be null. That is what I'm saying. Distribution I never talked about. The distribution of sample means it is about these numbers. It's not about this number. It is not about 4, 10, 50. It is about this mean number, different samples. So I have mentioned only two samples. More samples have been drawn for this experiment for this conclusion. So size should be adequate enough to apply the limit theorem. Why are people so confused with sample and population? Why give you two functions for sample, one for sample, one for population? You are completely confused. In scenarios, if you are going for inferential statistics, we just don't know about the population. It is too huge. Manjunath, mean of distribution of all samples is not mean of distribution of all samples. I'm talking about the distribution of sample means, not the mean of distribution of samples. Why are people so confused? One or two of you are very confused. Let me tell you. Let me indicate your confusion. You have taken out one sample as just for. Suppose you have taken out a sample of size 2, 4 of experience, 6 of years experience. Another sample 2 and sample T. Why not double? Yeah, we have these samples. Suppose there are many more. I'm saying that if the population distribution you don't know, the population distribution, population is not normal, population may be normal. And if the sample size is adequate, then the simple means. So simple mean for this will be 5. For this, mean will be 4. The sample mean will be 0.5. For sample mean will be 15. So what I'm saying, these values 5, 4, 4.5, 15, the values will be normally distributed. That is what I am saying. population distribution you don't know about. You can't random or uh, whether it's normally distributed or as binomial distribution or it has Poisson distribution. Don't know about population distribution. Taking out sample and use this theorem. Yes, you are right. Okay. Established this one big fact that if we don't know about the population distribution of sample means, I'm sorry, the distribution of sample means will be normal. Say this is not enough. We all know that distribution you need the values of two parameters. Unless you know those two values, you can't do anything. Those two things. For distribution, you need the values of two statistical parameters, without which you can't use any function, without which you can't do anything. Yes, Nagesh, you're right. So we have that this distribution of sample means distribution will be normal. This is something we have understood, but don't know about the mean and don't know about the deviation. These two things we don't know. So limit theorem tell about the mean and the standard deviation of this distribution as well. What that thank you. So we know that it is a normal distribution, but we don't know the mean and the standard deviation. Let me tell you guys, the mean of distribution of this distribution will be equal to the population mean. Is of this distribution, then the deviation of this distribution, the deviation of this distribution will be equal to the standard deviation of the divided. Give me a minute, I'll be back. Back in 1 minute.
you? Am I you? Thank you. Thank you. Some connectivity problem, I believe. Yes, I agree. Today, as I have changed the place. Okay, so I'm in my hometown right now. So maybe because of that, there is some connectivity problem. Thanks for bearing with me. I want to discuss here. Tomorrow is Diwali. I'll be in the outskirts, and it will be difficult for me to take the class tomorrow. So, if you we talk about arranging some other dinner, uh, but opinion, we want to push the classes by one. Uh, we can push that. Okay. So let's push this class, this session by one session, because you have gotten familiar with my way of teaching. Different trainers have different ways. Only day, one weekend, only one day we have lost. Uh, uh, we'll be the classes for tomorrow's session on the weekend, on Saturday. Yes, no, for sure. Aware of this fact that these are weekend classes and you people are free on weekends. Weekends, no weekdays. Such. And if you people also would like to focus more on celebrating the festival, so do it. Thank you. To those people who are uh, India, and thank you so much for your cooperation. Oh, yes, I mentioned this thing only on weekends. Okay. So, come the whole thing for you. I highly apologize. I really apologize for this, but this up at the very last moment. I'm. I know the big inconvenience caused to you, but uh, so the understanding, Balaji. Stats book. Yes, statistics you can go for. A good book by Amir and Excel. You can get that book on easily. I'll from Amazon for that, but let's go for that book. 2 sessions. Complete until hypothesis testing, and then go for that. For that, you can try on Google. Google is the best to learn R. You can go conceptual part using this book, or there are some other books as well. Other books you can go for like managers using Ken Black, Ken B-A-C-K, Ken Black, or you can also go for statistics for measurement using by Levin and Robin. So pretty good. Books have different trainer. I'm a trainer and as a teacher, it's a long journey. So I have gone through most of the books present in the market. Let me share the link. Give me a sec. You can book. It isn't on Amazon. The name is Complete Business Statistics by Amir Exel. Okay. We have a break, Vikas. With that concept, and whereas no cell is concerned, it is very easy. You can download, then you can work on Excel very easily using that. And tutorials present on YouTube and Google that you can go through. As neural network is concerned, you might not be able to work on that with the existing knowledge of statistics that you have acquired through these classes. That required some good understanding of classification, super learning. Is yet to come. So let me quickly everything together what we have learned in central limit theorem. I talked about 3 books. One book which I would like you people to go for. This is a very good book for which I have pasted the link. Another I mentioned Ken Black. One more book I mentioned Levin Rubin. You can go for 3 books I have mentioned. You can go for any of these 3 books. There are many other presents. All books are good. Okay, so come back to central limit theorem and talk about these all things after the. So Let's weave everything together we have done so far. So central limit theorem might the distribution of population is normal. The distribution of sample means will all normal. Distribution of population is normal. The distribution of sample means will always be normal. Irrespective of the sample size. Second thing we learned. Second, which is more important, if I have the adequate sample size, of sample means will be a normal distribution with mean is equal to the population mean and the deviation equal to the standard deviation of divided by square root of n. This is all about central limit theorem. Anybody any confusion before we get into the question and solve the question? Get into the problem. Let's solve. Let's start off with a very basic problem. Which I want to discuss. Suppose during hour in a departmental store, the average number of shoppers is 448 with standard deviation of 21 shoppers. The probability that a random sample of 49 different shopping hours will yield a sample mean between 441 and 446 shoppers. So to attempt this question first, then come back after 1 minute. So I'm giving you 1 minute. What you focus on, you need not to focus on the formulae, not to jump into the numbers and the formulae. Try to understand the scenario and go for the formula. You have minutes to go for. To solve this question quickly, come back. done a few to do. It is 0.92. Okay. We have only one problem. The problem I have highlighted here with yellow. Problem. Am I to it? With to use limit theorem or not, what we need to do. So let's get the understanding of it. Suppose during any hour in a department store, the average number of shoppers is 448. So we already know about the population. So number of shopper is 448. It simply means that we know 448. This is thing we already know. Mu is 48. And deviation is 21. Distribution of the population and mean of the population, these two things have been given to you. What has been asked here? What is the probability of a random sample of 49 shopping hours? So now something has been asked to you about the sample. So for population you have the information, but for the sample, know the mu of the sample is lying between 446 and 441. You know the probability of sample lying between 441 and 446. Usual size, it is 49. Sample size is 49. More than 30, sample size more than 30 is considered to be an adequate sample size. Size is 49. It is an adequate sample size. So if an adequate sample size, know that the distribution of sample means. So this is sample mean only. Design only. The distribution of sample means this will be a normal distribution. You already know. So this distribution of will normal distribution. So 441 will lie on this x-axis only. Will also lie on this x-axis. We know from the central limit theorem that mean of this distribution, mean distribution of sample means will be equal to the population mean, with 448. 448 is the population mean. Standard deviation of this distribution will be equal to the standard deviation of the population divided by square root of n. What is n? N is 49. So square root of n will be 7, and the expression will come out to be 3. Not understand till now. Which I have tried my best to explain you. How many of you could not understand so far? For is adequate. And that theoretically is going to be adequate, but in real life scenarios, it's a subjective decision. Subjective decision, sometimes even a sample of 500 doesn't help you. It's inadequate to accumulate more, to have more variations. More should be, in fact, it can represent the whole population the best possible way. Okay, very subjective. It again. You the information about the population. You know the population mean. You know the population standard deviation, which is 21. You know the population mean, which is 448. Find out for the sample. You need to find out the probability of still mean between 441 and 446. This thing you need to find out. The 7 to you, 59. I said it is sufficiently good. If it is adequate, from the limit theorem we learned that the distribution of sample means, so the sample mean only, the distribution of sample mean will be no. Sample means will be normal. So 41, 446, these all values will lie here on the x-axis, and we are looking for the this sample means. So we have understood it that the sample means will be a normal distribution from the central limit theorem. We need the mean of this distribution. The mean distribution of sample means will be equal to the population mean. This is also we understood from central limit theorem. A deviation, if you look at this, of this distribution was population mean. Deviation of this distribution was equal to the standard deviation of the population divided by square root of n. That thing. So T1 is the standard deviation of the population done by the square root of sample size. 10. So the distribution of sample means will be 3. Question? Now in this curve, we know the probability of the sample mean bit 446 and 441. So 441 lie here, 446 will lie here. You need to find out this probability. We all know how to find it out. This is which we got expertise on. So we can find out the difference between two probabilities. So from 46 or 48, minus P 441, 448, 3. Is it difficult? We talk about the formulae. Formulae will remain the same. It is about the concept and how you apply that concept. Martin, both of you are right. Very good. Now, how many of you are facing trouble? Considered to be a bit complicated, but we have spent a lot of time, and most are able to understand it. If you're not able to, I can explain it to you with the help of the example. That's what you need to do is Arya and others. You must of all plot it. You must of all visualize it, understand the issue, then into the solving. Sorry, I missed few parts today. Is the standard deviation of the distribution of sample means, which you will find out by dividing the standard deviation of the population by of sample size. So 21 divided by square root of 49. 21 divided by 7. That's 3. Okay. To make it more clear, to give you another example, I've put more situation here, very similar to the one which we have just discussed, but to give you practice to make you more confident center limit theorem, please solve this very quickly and let me know the answer. Solved it very quickly. Great. 0.3820886. Problem, try to rate what is the sample, what is the population, how we are connecting population with the sample. Different answer 0.0227. Ravi has rectified, come up with the same answer as of Ravi's previous answer. Okay, let's do it quickly. Maruti makes a 2.4 liter V6 engine, the laser XRI used in speedboats. The engineer believes that the engine delivers an average power of 220. And the standard deviation of the power delivered is 15 horsepower. So let's try to understand this problem. Copy it. So the information about the population has again been given to you, is equal to 20, and the division of the population is 15. Now, actual buyer is to sample 100 engines. 100 engines are sampled, so sample size is 100. Mean will be less than 217. Again, sample mean is being discussed. So to look at the distribution of sample means, adequate enough, it is 100. The distribution of sample means will normal. I'll keep it like this. Mean of this distribution will be equal to the population mean, which is 220. The deviation of this distribution will be equal to the standard deviation of the population divided by the square root of n, which is 10, will be 1.5. Now something has been asked to you. You need to find out the data sample mean will be less than 217 horsepower. 217 will lie somewhere here, and find out this probability. Now again, this thing you people are expert on. You can solve this question. Question P norm 217. It is very straightforward. 2 comma 1.5. T comma 1.5. Zero 227, which I believe most of you got answer as wonderful. So it really means that you are following wonderful. So it's time for all of us to grab the concept, and now we people know how to do it. Wonderful. Yes, I understand people find it complicated. Now we have gone beyond that. We have understood the concept. Now let's use it to in population. Let's use it for the estimation purpose. I'll show you how. I would request you to look into the problem which is mentioned just below that. COMST, the Computer Services Company. Read through this problem and see what this problem is expecting you to solve. Can you express your views? Yes. saying find the population size. Okay, and what it is asking you for. Comcast, a computer services company, is planning to invest heavily in online television services. So, services is an area Comcast wants to invest heavily. So, how that decision? Make a decision to estimate the average number of online shows a family of 4 would watch per day. Okay. Whether it is Q norm or P norm or what those are. But first of all, find out what we do as a so company needs to estimate the average number of online shows a family of 4 would watch per day. This thing Comcast needs to estimate. It is but obvious that it will be very difficult for Comcast to reach each and every family, go and do the market research for millions and billions of families and find this answer out. Obviously, it will have to go for inferential statistics. It will have to go for some sampling. So it set out. It created a sample of this 100. So it visited 100 families. From that 100 families market research. So it did a market research on 100 families. From that market research, average number of shows viewed by those families. So sample average can easily be found out. Sample mean can easily be found out. Sample mean came out to be 6.5. Standard deviation is known to be 3.2. Need to find out unit the number of online shows a family of 4 would watch per day population to generic observation, something for the whole population. So let me tell you, he'll be finding out the estimate. Interval estimate, I to say, tools we will doubt which we will expect the fall. We all estimation. Most of our time we do the estimation using interval estimate. We found one interval and we expect a value, the required value to fall between those two numbers within that interval. Time interval, we need to have an understanding of confidence interval. The concept of confidence interval will come. So now I believe you're able to understand the problem. Once you understood the problem, solution will not be that difficult. How many could not understand the problem? So basically, you find something for the whole population and you have a sample. From sample, you need to estimate the population. Anybody else? Two, three of they come later. I understand the business. All those things I will be explaining. Again, explain the things. I solve the question. I only want you to understand the problem. Solving is there a problem? So Comcast wants to invest in on television services. Okay. to invest in television services, online television services, it needs to understand the number of people, how watch TV, how many online shows that wants to estimate. Comcast basically wants to estimate the average number of online shows a family of four would watch per day. How many shows a family of four would watch per day? If you like to invest somewhere, you would like to see what area is. So if you want to invest in online television services, you would like to see how people are actually watching television, how much people are watch television, how many hours people are spending on television shows. This. So let's do it step by step. So understood this point, Nikhil? And Comcast is going for estimating the average of online shows. Good. So Nikhil, you have understood this basic point. Lokesh, are you? Good. Now do this. Good. So will you go about what you will do? You will each and every family. You will reach each and every house and would ask how many hours you saw television shows. So the number of television shows only, not about the hours. Number of only. So what you will do, you will reach easily ask people how much number of shows they watch. It's difficult for you. Get millions and billions of families, millions and billions of houses. Information about that. You will collect a sample. So you will pick up 100 families. Those 100 families, you will collect the data of average number of shows viewed per day. From there, you will find out the average number of shows viewed per day, and that number you found out as 6.5. Have you now? And Lokesh, till this you have understood? Good. Now the division of the population is given to you as 3.2, and you to find out the average number shows a family of four would watch per day. For that, what I'm asking you to find out the interval. Don't search out the exact number. Difficult for you. When you go for estimation, you will see a interval estimate. So what is required here? You should answer in this way. The number of shows of 4 would watch per day lie between x1 and x2, and this is something I can say with 95% confidence interval. Statement which you are expecting as an answer. Confidence interval, things will be explained to you. But have you understood the problem and the answer which we want? Very. How about solving this? the X here and PF here distribution, and the equation we saw divided by 2 by sigma per minus 1 divided by 2 and minus divided by sigma. In this equation, if you put mu equal to 0, if you put mu is equal to 0, standard deviation as 1 equal to 0 and standard deviation as 1. Get a normal distribution like this. In this, I put mu is equal to 0 and the deviation is equal to 1. The statistic which we refer to X now Z. This is called standard normal distribution. Normal distribution. So if you see what we have done here, we kept X minus mu divided by sigma. That is what we have done here. For standard normal distribution, the stick the x-axis as z equal to x minus mu by sigma. Convert any type of normal distribution on standard normal distribution applying this function. Try to look at this function, what I have done, and let me know if you have not understood it. Very simple. What I have done as well. Another statistic which we have defined in this way, x minus mu divided by sigma. If the normal distribution for z, it will be called standard normal distribution. For this, the mu be 0 and the standard deviation will be 1. So that we can understand the concept, so they can solve that problem. And to answer your question precisely, if we can convert anything on z, we can do anything because already know the value of mu and sigma. Mu is 1 and sigma is 1. Standard normal distribution because of that. You have standardized the things. With that problem that you can understand the business context and then explain you different and techniques which will be helpful to solve that problem. That's all I'm talking about. Okay, so that you all are able to understand. Let me tell you one more thing here. We would require to standardize the values time and again in different statistical techniques. I've heard about the process called normalization. You may come to you and ask you that first of all, normalize it, normalize the data, standardize the data. So what do we standardizing or normalizing? What we do, we subtract each and every element of that variable by its mean and divide that by standard deviation to get a standardized value. And why is the any of z what unit of z? Suppose x is in years. What will it unit? It will. How come? Navjot and Ankit both are right. It will be unitless. Look at x as in years. It will be in years. Derivation will be in years. Year divided by years will be unitless. So will be unitless. Has to standardize to get the unit. In that, well, with multiple variables, multivariate analysis, find out the distance between different objects. Are variables having different units? Sometimes we deal with time, sometimes we deal with years, sometimes money, sometimes height. Okay, so units we deal with, and all the variables in the same fashion. To make technique further, we might require to size all the variables. We might require to make all the variables unitless before we go ahead. So we use standardization or normalization. So an important concept we use a lot. I'll not be talking about the solution of that problem. I only wanted to make you understand the context before I explain you the concepts. So this is one concept which we'll use to solve that problem. Did we require to standardize things here? Yeah, that you will get to understand once I'll come to solution. So there are many other things which are remaining. We have the scarcity of time right now, but yes, thanks for asking this thing. You will get to know why we have learned here the standard normal distribution, what all other techniques are required, okay, to solve that question, to estimate the population. That will be done in the next class. That makes more sense, I believe, because we are already 3 minutes past 1. So let's keep it till only. Revisit, please revise whatever we have learned. Otherwise, concepts are building up. We'll have too many things, and there may be information overload. So please keep revising, revisiting all concepts, all the codes, whatever we have learned so far. Recordings will be on your LMS. I don't recordings. Okay. See you next weekend. Tomorrow we will not have class as discussed. So much. Happy Diwali to everybody. Thanks, Karya. Everybody.